Hi everybody. We are starting the second part of chapter 2 now, which we're actually starting with section 2.1, which is about relations and functions. So we've worked in the past on identifying domain and range, although we're going to review that today because it might have been a while since you've talked about that. And today we're going to focus on what relations and functions are, how to decide if something is a relation or a function, and we're going to use equations of those relations and functions and be able to classify them and do different things with them. So we have a bunch of vocabulary words that we will be seeing in this section. Most of them we'll talk about when we get there, but independent and dependent variables are not actually mentioned specifically in this PowerPoint, and so I wanted to make sure that you remember that an independent variable is our input variable, which is usually x. So it's what we plug in to get something out, which we call the dependent variable. So if we have a line, like we talked about in the first part of this chapter, y equals mx plus b, then my independent variable is x, and y is my dependent variable. So x is independent, I plug in my x, it's my input, I multiply it times the slope, I add the y-intercept, and I get my output y. All right, so let's remember first of all what a function is. We learned about this in Algebra 1. A function relates each element of a set, so in this case x, with exactly one element of another set. So basically what that means, practically speaking, is x cannot repeat. X is not allowed to repeat. X cannot repeat. So if this x is 3 and this y value is 5, I have to know that if I plug in 3, I'm going to get 5 for sure. I can't get two different range values for the same x value. On the other hand, it's fine that the range value repeats. So here you can see that this 5, I decided to label it, is used twice. So it's fine to have 3, 5, and 7, 5. The y's can repeat, but x cannot. I have to know that if I plug in 3, I'm going to get 5 and only 5 if it's going to be called a function. This is another example of that. So this is not okay. The x cannot be used twice. This is fine. Y can be used twice. That's fine. If a relationship does not follow these rules, it's not a function. It's still a relation or a relationship of ordered pairs, but it cannot be considered a function specifically. There are two other kinds of functions that they talk about in this section. The first one is called a one-to-one function. This means that neither x nor y repeats. So each element of the domain is exactly with one of the range, and the range cannot be used more than once. So it's kind of like vice versa. So each x and each y is only used one time. An onto function basically just means that we use every element of the range. So if you look in this first example, C was not used. So this is a one-to-one function, but it's not onto. Onto means that however many range values I have, I use them all. And something could be both one-to-one and onto. That would be this picture. So each domain only goes with one range, and I don't repeat the ranges, and every range value is used. All right, so if we look at this relationship that's graphed here, we want to figure out if it's a function or not, and if it's one-to-one, onto, both, or neither. And we're also going to review what domain and range are. So if I write my relation out, this is the set of 5 ordered pairs that is graphed on this coordinate plane. Remember that the domain is the set of x values. The domain is the set of x values. So in this case, my domain is -4, -3, 0, 1, and 3. Notice they're in order from least to greatest. The range, which is the set of y values, is -2, 1, 2, and 3. So this is a function because the x's do not repeat. So we can say, yes, it is a function. It's onto because I use every element in the range, but it's not one-to-one because my range value of -2 is repeated. All right, this is one where we're going to pause. You're going to answer the question here on Edpuzzle and then come back and check. Okay, hopefully for this one you answered B. Your domain is your set of x values. Your range is your set of y values listed from least to greatest. And yes, it is a function because none of my domain values repeat. Okay, we have another way to test if something is a function. If we're looking at a graph, it can be hard to list off maybe every possible x or every possible y. So we have something called the vertical line test. This first picture represents something that is a function. In a function, if I draw a vertical line anywhere, it's only going to cross my graph once. If the graph is not a function, then if I draw a vertical line, it's going to cross it more than once. The reason that this is not a function is because this ordered pair would be like 1, maybe 1.2, and this ordered pair would be 1, negative 2.1, let's say. But notice that they both of the ordered pairs have the same x value, so this is not a function. So this is a visual way to figure out if a relationship is a function or not. So if you look here, we have this table. This table shows the fuel efficiency of a certain SUV by year. And they're asking us here, is this function discrete, or is this relation discrete or continuous? And then they also want us to figure out whether or not it's a function. So first of all, if we graph this, if we graph all of our ordered pairs there, and we use the vertical line test, you can see that anywhere I draw a vertical line, it's only going to cross one point. It's never going to cross two. So we would say, yes, this is a function. And then they have this terminology here of discrete or continuous. Let me go back and show you that real quick. Discrete is a relationship that's made up of individual points that are not connected. Okay? Continuous is like when we draw a parabola and it's one continuous curve. It's a curve that continues and never breaks off. We would say that is continuous. So if we look at this relationship that we drew here, since it's individual points, we say that this function, because we determined that it is a function, this function is discrete. The points are not connected. The function doesn't exist between the points. It only exists at those specific points. So we call it a discrete function. All right, you're going to answer a question about this on your Edpuzzle video. Here is your table, the average weight of babies for several months during the first year. You're going to graph it and figure out if it's a function or not. All right, hopefully you answered A. You can see that when you graph, it is a function because a vertical line would never cross it more than once. Age is in months, the weight is in pounds. This is the graph that represents the best graph of the ordered pairs in the table. All right, if we're graphing a relationship, we learned how to graph y equals 3x minus 1 in the first part of this chapter. So here they're showing you to make a table of values, but we already know that we would just graph the y-intercept of -1 and a slope of 3. You can see that if you make a table of values, you still get the same line, right? Here's my y-intercept of -1. If I go up 3 and to the right 1, up 3 and to the right 1, or down 3 and to the left 1, I'm graphing a slope of +3. So this is a function because it passes the vertical line test. No x values are repeated more than once. This function is also continuous because this is an equation and I can plug in any x value I want, fractions, decimals, positive, negative, 0. Every single x that I choose is going to be defined, and so when I graph it, it makes a connected straight line. So we say that it is a continuous function. The domain and range, when I'm talking about something that's not specific points, can be a little bit tricky, but it's not too bad with a straight line. If I think about my x values that I can plug into my equation, remember that my equation is y equals 3x minus 1. I'm allowed to plug in any x I want, like I just said, positives, negatives, fractions, decimals, square roots. Any real number I plug in, I can multiply by 3 and subtract 1. So that means that my domain is all real numbers. And if you think about the vertical part of this graph, all of the y values, if I extend my graph forever in both directions, no matter where I go on the y-axis, I will always find a piece of the graph that goes with that y value. So for example, if I'm looking at this y value, the function is defined there. If I'm looking at a y value down here, the function is defined here, and my function goes infinitely up and infinitely down, if you want to think about it that way. So the domain and the range would both be all real numbers. If we're doing that in set builder notation, this would be the set of x for the domain, the set of x such that x is in all real numbers. And the range would look the same. The range is the set of y such that y is in the set of all real numbers. This, like we already said, is a continuous function because it connects all the way along. The domain and the range are both all real numbers, and so I'm going to connect this infinitely in both directions, and it is continuous. So in this we already said this, but it's already a function. In this case, it is one-to-one, meaning each x and each y is only used once, and onto, because I use all the real numbers in the range. All right, stop and answer this question. Hopefully you recognized it as a y-intercept of 5 and a slope of positive 2. All right, last but not least for this section, we have function notation. This is something that should look familiar to you as well. We read this as f of x equals x squared. So this f is the name of our function. It can really be any letter. We use f a lot, but it could be g or h or really anything. This variable right here shows me what my input value is, and this part here tells me what the output is. So we would read this as f of x equals x squared. F of x says this is a function called f, and x is what I plug into this function. And this x squared says that when I plug in x, what f does is it plugs x in and it squares it to get a y value. So let's look at this here. We have f of x. Remember, this is f of x, not f times x. This function equals x cubed minus 3. So I'm going to plug in an x, I'm going to cube it, I'm going to subtract 3, and I'm going to get out a y value. F of x is like my y. We're going to find f of negative 2. Remember, what's inside the parentheses here tells me what my input is. So I'm going to plug in negative 2 for x. So f of negative 2 equals the quantity of negative 2 cubed minus 3. When I cube negative 2, I get negative 8. Negative 8 minus 3 is negative 11. So f of negative 2 equals negative 11. That means when I plug in negative 2, I get negative 11. That is an ordered pair on my function. The point negative 2, negative 11 has to be on my function. All right, sometimes we can plug in something that is an algebraic expression instead of just a number. So in this case, we're going to do the same thing. We're just going to plug in 2t. So when we plug in 2t, we put it in parentheses and we cube it. 2t cubed means 2t times 2t times 2t. Because I'm multiplying it by itself 3 times, that gives me 8t cubed minus 3. And that's as far as we can simplify because we don't know what t is. So f of 2t just equals 8t cubed minus 3. Just leave it like that. All right, I want you to answer this one for me, please. All right, when we find f of negative 1, we get d, 6. Negative 1 squared is positive 1, plus 5 is 6. And let's do one with an algebraic expression. So in this one, you're going to find f of 3a. When you simplify, you should get d 9a squared plus 5. All right, that is the end of this section. I will see you in class to practice everything about functions and relations.